one. All right, let's see if this is working right. Hopefully you can hear me. Let's see. And hopefully I can advance the slides. Let's see now. Oh, come on. Oh, that's why. All right. Welcome back. David Hedley. I think this is an important topic. That's why I'm doing it. I've got 25 years in IT, 20 years in network engineering. Decided to start creating a series. I think some of these things are important. I see people that have a lot of experience in the industry and they're missing out on these things. Some of the topics are going to come from my experience going to some of my training classes, and some of my compatriots in other companies, other industries can really benefit from some of my experience. So that's what we're going to do with this series. You can suggest topics. Let's kind of dive into this. So let's see, does it work? Oh, come on. Yay, okay, the slide changed. So learning and technology, bear with me. And again, I really hope you can hear me. So just so you know, the specific brands and models are for illustration purposes only. They do not imply any endorsement by the vendor in any way. I only include equipment that I have experience with, so I can talk about it more intelligently. And at this time of writing this presentation, I have not received any compensation or inducement for any vendor. So to be clear, I'm talking about Cisco because that's what I have experience with. Okay, basic definition: redundancy in engineering of a device, circuit, computer system, etc., having excess or duplicate parts that can continue to perform in the event of malfunction or some of the parts. That's from dictionary.com, and that really refers back, if you go to our opening subtitle here, making failure something less than an emergency. I love my wife, I like my dog, I like my sleep. So having redundancy means I can have types of failures and still be able to sleep through the night, even when I'm on call. And I think that's important. And it also means that we can have failures right during the peak business hours and still be able to continue business. And it's that difference of, particularly when you're the engineer that's responsible for getting these systems back online, the difference between a C-level, a VP, or even a director breathing down your neck every second. This is how much money we're losing every minute this thing is down. Not a comfortable place to be in. They're still very interested when a critical system has gone down, but when it's redundant, at least, hey, we're not impacting our customers. We are still functioning. That's the important part here. And the reason I'm talking about it is that so often we do something really stupid, frankly. So we lose that redundancy in one single decision. And so that's what we're going to walk through tonight. So I want to introduce this topic of logical OR versus logical AND, and the reason this is there is these truth tables is a non-redundant system is an AND. So if we take the false value as offline and the true value is online, first, if a system is dependent, not redundant, everything has to work for the system to work. So when you look at just that table on the left, you'll see that there are 4 possible states. 3 of them are failure states. Only one of them is an operational state. With redundancy is a logical OR. If this is working or that is working, we're still online, that we're still up and running. And as you can see in the truth table, there are 3 of the 4 operating states where we're still functioning. The ideal state, obviously, in redundancy is to have both your primary and your secondary available and online. But whether it's my primary, my secondary, or if I'm running active, that they're both running or one or the other is running, I'm still running. That's the key discussion here. As I said, the purpose is making failure something less than an emergency. And here's the question that should focus our discussion. Is there anything in the current configuration that, if it fails, will take down my customer? So thinking of quality, when you think about the lean or the utility production system or any of the quality systems, that's one of the things that when you're now, uh, this is where your customer does want to pay to make sure that you stay up because they want to access their Netflix or whatever it is. They don't want that to be down when they want to use it. So let's take a look. Introducing a second concept, and this will come up in other talks as well, on this, the triple constraints. It's a concept from project management. There are three interlocking, there's three interlocking concepts: time, quality or scope, money or budget. You can change one of those without impacting the other two, but you can't change two, and you certainly can't change three. I can't do something faster without affecting either quality or how much I pay for it. So that comes into this. This is an important concept because obviously when you talk about redundancy, I can reach absurd levels of redundancies. So having like redundant data centers on every continent, including Antarctica, and Microsoft is apparently dropping pods in the ocean, test pods of servers in the oceans. I can do that if it makes economic sense. Great, but if I'm running an Etsy store, having redundancy of like undersea pods is probably overkill. I'm just saying. So in the first area, I just want you to start asking that question of, is there anything that can take me offline? Let's talk about power for a second. So even if I don't have an uninterruptible power supply, UPS, just basic utility power, if I have redundant power supplies, did you plug them into the same outlet? Or are the outlets they're plugged into on the same breaker? PDU, whatever it is that you're plugged into, if you have redundant power supplies, just moving them to two separate circuit breakers makes a difference. It's possible then in a case where I trip one circuit breaker that I'm still online. With a UPS, this is still relevant because if you look at, for those that are running 110 power with the outlets on the back, they're typically broken up into groups, and there'll be a circuit breaker for each of those groups. So if I took my two plugs, plugged them into one of those groups, so they're on one circuit breaker, again, one point of failure. If I move them to different ports on the UPS, and I can do that while it's running, as long as both power supplies are up, I literally can unplug one and move it if I had to. I have a higher level of redundancy. Obviously, adding a generator to that equation adds the redundancy. So because you have to recognize UPS is not built to run for hours and hours. When you need to run for hours and hours, the UPS is gigantic. You have a lot of batteries. Most people don't buy that many batteries. So your runtime may be minutes. A generator, you need the UPS when you have a generator to allow the generator to come online and up to speed. But now you can run for hours based on your fuel supply and your ability to refuel the generator. I'm not talking about like a Honda portable generator. I'm not talking about a little generator. I'm talking about something significant. And some have a suggestion, even when you have the UPS, if I have redundant power supplies, I plug one into the UPS and one into house power. So if the UPS fails, I have a way out. The downside of that one, the one I don't like so much, is that utility power, the UPS conditions power, the utility power, I can get a spike that fries the power supply, and that may void my warranty. So that's my thought on that one. But it is another way to go at redundancy, that I'm protecting myself from another type of failure. And so I go through the other things to do here. Again, if you're just on utility power, don't plug them everything into the same breaker. On your UPS, also do make sure, buy the web cards if it doesn't have it built in, and configure it. Get your alerts, know when the battery's dead, know when it fails its self-test, have it run regular self-tests, so you're sure before you have the failure that the battery is still good. Now, the batteries will deteriorate over time, and don't forget that you need to have proper air conditioning, otherwise the batteries will fail much faster, and they may actually bulge and no longer be replaceable. They're stuck inside the UPS and you have to throw it out. So there are some things you need to do. Obviously, if you have a generator, there's generator maintenance needs to happen. You need to have your refueling. You need to know how to get it refueled once you've been on running for a while, right? So those are important questions to consider when you're talking about redundancy. Um, and again, these are some of the questions. Do you know if your batteries are still good? So have you been running those self-tests? If the room gets too hot, will your UPS shut down? So again, heat's an issue. A lot of things like APC, there's temperature probes that you can have on your UPS that you can trigger them to do a graceful shutdown. So you shut down the whole data center if the heat gets excessive. I had a data center once hit 114 degrees Fahrenheit. Yeah, that damaged equipment. It did. It was a significant failure. Three supposedly redundant air conditioning systems all failed due to a common short. So that was bad. If I'm using power distribution units, are those redundant? Do I just have one? And if sometimes, yeah, they're one. So the UPS may have an L530, so a 30 amp twist lock, 110 volt out to a single PDU, but that PDU may have multiple breakers. So split the loads, right? Does my device have redundant power supplies? The older Cisco stackables, you needed to buy a separate redundant power supply. The newer ones, hey, it's got a slot right there. We're going to talk more about that shortly. And then this other question, is my power cable secure? So if there's any kind of tie downs for that power cable, use them, because that's that keeps the oops, somebody bumped up against it or was tracing some cables and they pulled the plug right out of the back. Those universal power cords have that disadvantage. All right. A question about, is your UPS right sized? If you're running that thing at 100% load or close to it, it's not going to run long. Minutes, a couple of minutes. You may need to have something that runs longer. There are tools like at APC here, and if you look at some of the other manufacturers, for full disclosure, I was an APC certified reseller for years. There are other manufacturers have white papers or others to help you calculate that. It's good to run through that calculation, right? And do I have enough power for all my power over Ethernet devices? That'll also go into things like cooling and the rest. If I don't have big enough power supplies, I'm going to be in trouble. Okay, so I want to talk a little about the Cisco Power Stack. So this was introduced with the 3750X. You'll see it on the 3560s, 3850s. Put the Power Stack in for Pete's sake. It's simple, right? So, and put them all in. Every time you buy one, they give you a power stack cable and the data stacking cable. Use them. And make sure they loop. So if you see in the drawing, the top one has a connector to the one below it, and then the one below that, and then the one below that has the one connection to the below that, and it keeps going all the way down to the bottom, and then loops back up to the top. This way, I can have multiple failures and I have enough power in that stack especially if I've bought the redundant power supplies, I've got enough power in that thing to do a lot. So if you have already paid for it, do it. Whenever I see a 3850 and they don't have the power stack cables, I just get a bit upset about the whole thing because it just should be done. It's there, use it. Okay. If you're using Liebert UPS, okay, they have these micropods. On the larger UPS, they're built in, but on the smaller ones, it's a separate device. I see people not buying them or not installing them correctly. So if you look at the drawing here, this is from their data sheet, which is referenced in the presentation. There's a cord that goes out to utility power, and it's labeled. There's one that plugs into the UPS that then powers up these outlets. And there's a plug there which you plug the UPS into. And so that way you'll be able to switch from house power to UPS and back and forth. And again, this thing has two sets of breakers. So the right and the left are two different breakers. So if you put all your plugs on the left side or the right side, they're not redundant. You have redundant power supplies, but that one breaker on that pod goes offline, you're down. And I like the pod because if the UPS does fail, I can quickly flip that switch over to house power. I'm not replugging anything. I don't have to figure out how to make this work. I go back onto that. I get the UPS repaired or replaced and plug it into that cord right in the middle, and I'm back online. when everything's up and running, the light for the UPS ready comes online, you can switch back over to secured power. So again, this is an inexpensive add-on to your UPS, and you should be using it, right? For network, if one is good, two are better. I sort of mean that. I'm going to ask about things like, so if you have a server, a lot of servers have some sort of remote management, whether it's called ILO or DRAC, Dell, or remote access. Is that capable and configured? Because one of the things, particularly when you're on call, the ability to go online, attach to that option, and see what's happening. And in some cases, that'll allow you to do things like reboot the whole system, like power cycle the system from there. Do it. If you have multiple NIC ports, so network interfaces on the server, okay, are they going to different blades on a chassis, different stack members, or completely different switches? Because that's actually really important. A single blade can fail, but if the chassis is still up, if I have those connections spread out among different blades, my server's still up. I lose some bandwidth, yes, but if I team the NICs, which was the next question, and I have them spread out, or I even spread them between two entirely separate top of rack switches, I can lose one of those switches, or when I have to reboot it to install new code, then the server is still up, right? If it's a switch and it's stackable, are both stack ports connected? I've seen in some cases one stacking cable between these two devices when two are supplied. Why? Oh, I lost it. I'm going to make you a bet if you open enough drawers, you have plenty of spare cables, because Cisco tends to ship a stack cable and a power stack cable with every one they ship. So just do it. Does a switch have at least two physical connections to the cores, distributions, routers, etc.? It's another thing that makes me kind of crazy. You have one uplink. Why? So one point of failure, that cable gets unplugged, that either side fails. Because when you think about it, now you have multiple different pieces that all have to work right for that to stay up. So don't do a single connection. Whenever possible, use port channels, ether channels, right? And Steve's right, LACP, PAGP for Cisco proprietary, even lag, which the Cisco WLCs use. Do it. And it can be layer 2 or layer 3. It doesn't matter. The nice thing is, if I put two connections up and they're layer 2, spanning tree is going to shut one of those down. If it's a port channel, spanning tree sees that as one entity. So I can have either one of those links fail. There's no change in spanning tree. There's nothing happens. It just keeps going. And for layer 3, okay, I have two different layer 3 links. Right, I can have two equal cost paths, and so the streams are load balanced across the two links. If I do it as a port channel, if I lose a member, I'm not having to go and announce, I'm not flapping routes. It just keeps going. Is your spanning tree mode rapid? So quicker convergence is a huge value. So if I did have those two separate links, the sooner a failure is detected and acted upon if I'm using rapid. If it's needed, do you have HSRP, hot standby router protocol, configured on your VLAN interfaces? Right. So I've seen some things where somebody didn't put a standby subnet on both of the HSRP interfaces. Right. You got to look at these things, make sure they're right. I've also seen once an HSRP that was inappropriate. There was a replacement router. So original router, new one gets put in, HSRP back to the layer 2 switch. When the other circuit was decommissioned, no one ever took the second router offline. Now, it wasn't that bad. If the primary network link went down, the WAN link went down. So someone testing at the site could say, I could still ping the router. It'll confuse people. but we won't realize that it could actually be a router failure. We're thinking it's a circuit failure, and it may not be because of that was left in place. Now, I also really like the Cisco Virtual Switch System, VSS. So if you use, say, the 4500X chassis, which is essentially a SOUP 7 with up to 40 SFP plus ports, build them into a VSS. So logically one unit, and all my feeds in there can be built as port channels, layer 2 or layer 3. So very stable. And I could use ISSU in-service software updates to do a code upgrade on the VSS to make it transparent to my users, to make this as transparent as possible. Cisco Nexus. Well, Nexus has all, hey, we don't do spanning tree, everything's up. That's not quite true. There's some loop avoidance technology that's built into it, but the idea is I can build this big fabric path and have lots of redundancy and have high availability. So that's what Nexus is built for. I'm moving on to just a simple network design, and this is these are using Cisco standard symbols. So you've got the router is the round thing on the top, and the basic layer 2 switch is the bottom there, the rectangle on its side. First thing I'm going to say is always on that uplink interface, build it, if the layer 3 is on the router, build it as a trunk port. That way, even if right now I have one data VLAN, that's all I'm doing, later on I need to add something, a voice VLAN, say, if it's a trunk, it's easy to do. It's easy to add. I add the new sub interface for the new VLAN, and I add the VLAN onto the switch. We're done, right? Just make your life simple. Do it as a trunk port. One of the features that was introduced in the Cisco 3900 series, that generation of equipment 2900s as well, was the auto failover, media type with auto failover. So one of the challenges when I build it this way is that I can't build two interfaces on the switch that both have that VLAN, that .1 interface, the VLAN gateway. With auto failover, I can have one interface. I wire the copper, I wire the fiber. Depending on how I create that statement, so I do media type RJ45 auto failover, on boot up, it'll try and use the copper link. If the copper link fails, it'll turn up the fiber link. Now, when I do that, if this is a stackable set of switches, I do it so I have the copper going to, say, stack member number 1 and the fiber going to stack member number 2. If I'm going to do the redundancy, if I have them go to both the same stack member and that stack member fails, no joy. The site's down. And if I have the links set up that way, at least I'll be able to get into the switch and see that one of the members has failed. So when I go to deal with the problem, that assuming it's not at a site where I have spare parts, it's one of my remote sites, I know I need to grab another 3750X or a 3850 and bring that out to replace this failed unit. But I can see that the stack's down otherwise. I don't know if I haven't built that redundancy. The other way you can go about this is a backup interface. So you define it on the interface, you backup interface. So if I'm on GI00, backup interface GI01. I have to build all the sub interfaces on that GI01, and you'll see that they're shut down. If you do show interface description or show IP interface brief, you'll see that they're in a shutdown state. They won't come online unless the primary fails. There are some failure modes where that's not going to help. If the switch logic fails, but it still has link, the router doesn't know to bring up that secondary link. But if this is a remote site, I could always do something like shut down the primary and see if the backup comes online and see if that helps with my failure. It gives me an option. In a broader, now we're looking at a layer 3, a router and a layer 3. Well, again, do you have 2 links? If you can't afford to put 2 links in, you need to get a bigger switch. Redundancy is that important that if I've got 47 ports and 48th is the router, I need to buy a bigger switch. I need to buy a second stack member because I need to have some redundancy. It's just, I'm gambling too much. Um, if you, it's easy to do in this case with a router. Routers can't do port channels, ether channels. That they can do. They'll be equal cost links, no problem. Make sure though on all the devices you put in the IP multicast multipath into your global configuration. Multicast has, and we'll talk about this when we get to multicast in a future talk, that with multicast, when it has equal cost links, it wants to do only one of those two links. So your multicast will become unreliable if you don't have that multipath in there, that multipath statement. If it doesn't need it, it doesn't do anything, but it's only if it needs it. So it's something that's important to put in all your multicast builds. Now, in a more complex design, this actually looks like one of my sites that I have, where I have two closets. The routers are actually both in the same closet as one of the switches. But the way I built this is that two links coming off each of the routers, one going to each of the two switches, and site has dual carriers, dual routers. So each of the two providers has a direct connection to the two switches, and there's two Ethernets between the switches in a port channel. So this way, I can have lots of different failures. I can lose a single router. I can lose a single carrier. I can lose one of those two switches, and the other switch still connects. Often what we're going to do, if I have those two routers in the same closet, I'm just going to put all the connections to that one switch. That switch goes down for some reason. That has a serious hardware failure that takes it offline. I've taken that whole site down. I've now lost half the site because its switch went down. That to me is still an improvement. I have fewer people, and you think about it in some of these environments. I work in the healthcare industry, so okay, worst case, I can have people check in the other half of the building or do their co-pays in the other half, a different reception area in the other half of the building. There's a lot of ways I can do this, that I can reduce my inconvenience to my customer. Or I can, if I need to go look up something like your medication, I need to put in a prescription for you. I can't, obviously I'm an IT guy, just to be clear, that you can go over to the other side, get it done, right? Rather than I'm just completely down. So that's an important, it's one of the things, you take a look at all the parts you have and ask that question, is there any single thing, if this goes down, it's going to take me down? In a case like this, that would be that one switch in the one closet if I did what most people do, and I didn't. And I did that on purpose. Now, a couple of other questions about diverse carriers. You got to recognize a lot of times when you are going with diverse carriers, you only get so much redundancy out of it. Most of them, they're housed in your telephone company's central office. Now, your cable provider may not be. Your cable provider never had to be in your central office like everyone else needed to be. So they may actually have a separate central office. And diverse carriers gives you that advantage. I was bit a couple decades ago when MCI did a giant upgrade on the frame relay network and took down a bunch of customers for weeks. It was a long time before they got that fixed. So if I had a redundant carrier, that site would have still been out, but it wasn't. It was ugly. And of course, we're going to ask these questions. Are the carriers actually using diverse paths? They don't want to necessarily show you all their cards. They don't. You work it out as best you can between the two carriers. Hopefully, you don't have common utility poles or anything else. So, but it can happen. There's always that you've done everything you could, and hey, both of them go through one utility pole. Somebody takes the pole down. It happens to the best of us. Here's some other considerations. So if you have a primary and a secondary data center, do you know how to bring services online or move them from the primary? So if you're supporting that secondary data center, do you know how to do that? Are there written directions on how to do that? Have you practiced it? Have enough people practice it beyond just sort of the designers? The designers practice it a couple times, but have the regular guys supporting it gone through that exercise? Do they know how to do it? Your clients, just something basic to think about, your DNS servers. So are they all located in the same data center? So if I lose that data center, if I have redundant internet connections in particular, or if I have distributed services throughout my network, so that will these users be down because all their DNS servers are in this one spot? Do you have a tertiary, a secondary that's somewhere else in case of this failure? Your DHCP servers, are they redundant? If they're on a single device, now, if you do it on the router, obviously, and you have a single router, well, when the router's down, the WAN is down. For a lot of us, when the WAN's down, we're pretty much dead anyway, so maybe it doesn't matter. There are times where you're going to say, meh, I just can't do anymore. But ask these questions. Are they local to the site? So if I lose the WAN and I still have local services, so I can still do my job, or at least a part of my job, if all the DHCP servers are somewhere else, well, I reboot my computer, I'm going to have problems. If I bring in my laptop and try and flip it on, it's not going to get a DHCP address, right? And then Microsoft at a certain point introduced failover, so you can have two DHCP servers. We used to do this by hand, where we'd go into the exclusions and set up so two DHCP servers were serving the same scope, and they serve different ranges of addresses. The new one, it handles it for you. One of the things people do sometimes, they mess up those exclusions. So I'll have both servers trying to serve the same pool, or they've made mistakes in the second server, say not define the router address, or put in a typo, or not put in the Cisco options for the wireless, or they don't have the right options in for phone if it's a voice LAN. The failover is nice. You do it right. You tell it to replicate to its partner, and it's done. So I recommend that if you're running Microsoft DHCP. And then there's this big question, which is a lot bigger than, say, just an individual engineer, but it's okay, if the WAN links go down, do we have the right services on site to continue working? We often have a lot of assumptions about what we can get done, but frankly, you have to think through everything it needs. Power and network and DNS and DHCP and all these things that all have dependencies on the ability to work. If you're thinking that site can still run, and you're missing some of those critical components, it's just not. It's worth exercising that if you can, to actually do a scenario where you shut down the WAN links. Okay, what happened? Can we still work? It can be a great exercise for your folks to go through of, okay, network's down. Do I know how to, right? To train not just the IT staff around outages, but staff need to know. My first job out of college was in the car rental business. We had a mainframe. Mainframe went down sometimes, and we had paper contracts, just like one of my employees used to fill out when she first started in 1969. So it was slow, it was hard for all of us. We weren't used to doing it, but practicing with those manual procedures are good to do. Now, some things can't be duplicated, right? It's good to know what things can't be duplicated, and it's some of the things like credit card processing. I need to get the internet to do credit card processing nowadays. So no internet, I'm sorry, I can't take your credit card right now, right? And then a number which is good for management is to know how much any outage costs us. And you as an IT person, that number can be really great as you're arguing to spend a little more money. That second power supply on a switch costs a little more money. Certainly adding a second carrier, adding a second router adds even more money. If it's critical enough, if that site being down for any length of time is going to cost, say, in the millions, okay, a single outage will more than pay for the redundancy. You don't like the expense. There's a thing of like, hey, I paid for all these backup circuits. They pretty much never get used, right? Pretty much never, but they do sometimes. Even if it's just for maintenance, the ability for us to do maintenance on a circuit or a device, we have a backup. It's good to know how much an outage costs so that you can run that back. So these are just some thoughts asking that question of, hey, is there anything, if this goes down, it's going to take my customers down? Ask that question, look at it all, right? Certainly now we've gone to VoIP, think about all yeah, so I need to do maintenance on the switch. Okay, well, they can call in if they, oh, wait, no, if the switch is being worked on, the phones are down too. Oh, shoot, how do we do this, right? Start to think about that and where the appropriate redundancy is. Sometimes, like I said, having, the server pods under the ocean that Microsoft is building, yeah, that's overkill, okay? But not for them. It makes sense. Thanks for watching. You can subscribe. All these videos are getting uploaded to my YouTube channel. That you can follow me on Facebook, which is where I'm doing Facebook Live, that those that are watching now. I repost the links onto Twitter, Instagram, and LinkedIn. And feel free to suggest topics in the comments, or certainly, what you liked, what worked, what didn't work. Certainly want to take a look at that. Next week, I'm going to start talking about voice deployments. Now, I'm not a voice guy. I build the infrastructure for the voice guys, which one of my listeners can testify that, yeah, it's my job. That I'm going to talk about the situation which one of my classmates not long ago when I was doing a quality of service class was going exactly through this. He's the infrastructure guy, and they said, hey, we got consultants going to deliver Cisco voice. He's a little overwhelmed by it, right? I have some tips, techniques. Now that's going to be a long series. We're going to do it in these half an hour, a little longer than I like to run, about half an hour shots of, it's going to be weeks of this content, kind of walking you through that whole process. So hope to see you next week. Tell your friends, subscribe, follow, do whatever you got to do. Like this, share it with friends. Appreciate you all stopping in today, and I'll see some of you sooner rather than later. Thanks for stopping in. Boom.